Hello there, this is a quick screencast to get you up and running with using Microsoft Excel to work with data as we are doing in section 1.2 of the Stewart Calculus book right now. Especially what we want to do here in this screencast is learn how to enter data into Excel, how to make a plot of the data, and how to fit a linear function through data. First of all, here I have Excel open. If you don't know where Excel is on your computer or how to open it, ask a friend or ask a professor. This looks different on different machines, and so I can't really go into that in the screencast. Anyhow, once you have Excel open, you see just basically a blank grid of cells here. What we're going to do is enter in numbers and other data into these cells and work with them. We're going to be working with Excel quite extensively, and we have more detailed basic screencasts coming. So we're going to be working particularly with exercise number 22 in section 1.2 of Stewart, and that's on page 36 of the book. And it has some temperature here, and then chirping rate. To move from cell to cell, I can either hit the Enter key, or the arrow keys, or the Tab key to go from one place to another. I'm going to enter in the data as they appear here, getting started, and let's type 50, and then across from 50 is 20. I hit Enter to go to the next line, 55, and I'm hitting Tab, or I can use the arrow keys to get to the next cell, 46. And I'm just going to continue to enter in the data. Unlike the way the data appear in the Stewart book, which is in 4 columns, I'm going to create just one pair of columns. That will help me in the plotting. So I'm going to take a break and type this, and come back when I'm done, because watching me type is not really exciting. Okay, so here I have all my data entered in from the book into one column for the independent variable, another column for the dependent variable. And the first thing I'd like to do is create what's called a scatter plot of the data. This is just simply plotting each of the data pairs here, like 50, 20, 55, 46, as an XY pair, and I will end up with 9 dots, in this case, scattered throughout an XY axis, so that's why it's called a scatter plot. To do this, I'm going to take my mouse and I'm going to click and drag to highlight all the data. Oops, sorry about that. Click and drag to highlight all the data I have here. Let's leave off the labels, and then I'm going to go insert a chart. This is on a Macintosh. It may look slightly differently on a Windows machine, but we're going to go to Insert and then Chart, as you see here. Whatever that looks like on your machine, insert a chart. And then we're going to be given some options here for the kind of chart we want, and XY scatter is what we really want here. So I'm just going to click on this, and it gives me some more options. Do I want just the dots? Do I want to connect them with curves? Do I want just the curves and no dots, and so on? Let's just make a dot plot like so. Click on it, and it will think for a moment, and there it is. Once I scroll down a bit, we see the scatter plot, and those are my points that I were in my data set underneath this graph. And here they are as a scatter plot. So next it asks us to find and graph what's called a regression line. What is a regression line? Regression line is the line that best fits the data that you see here. Now these data do not perfectly line up along a straight line. There's a little bit of kinks in the arrangement here. But if I were to fit the best possible fit line through here, I'm kind of putting my mouse to where I think that line might go. The line of best possible fit is called the regression line, and Excel will generate and graph that automatically, and here's how we're going to do that. I'm going to go into my data and put my cursor on one of the actual data points in the graph, and then right-click it. When I right-click, all of the data points, all 9 of the data points light up, and we're going to add a trend line to the data. So I'm going to select Add Trend Line, and this will bring me to a dialog box. What I want here is to change the type to linear. Okay, and notice it says regression type here. So a linear trend line in Excel is what your book is calling a regression line. So I'm going to select linear, and I'm going to click OK, and you see the line of best possible fit through here. And again, it's not a perfect fit, but the data are roughly linear, and so this line is a pretty good fit. So that gives us the regression line, and it says use the linear model in part B to estimate the chirping rate at 100 degrees Fahrenheit. To do that, I'm going to need an equation for this line, and Excel will generate that too, in fact. I'm going to go in and click on the line, actually right-click on the line, not the data points, but the actual line, until I get this menu that says Format Trend Line. So Format Trend Line, and I'm going to go to Options, and ask it to display the equation on the chart. And when I do that and come back, it actually displays the equation on the chart. The x here refers to whatever's on the x-axis, and that was the temperature. The y is whatever's on the y-axis, and that's chirping rate. So if it asks, for example, to estimate the chirping rate at 100 degrees Fahrenheit, I would just simply plug in 100 for x in that formula and crank through it and see what I come up with. Okay, so that's a quick overview of how to enter data into Excel, how to create a scatter plot for them, how to add a regression line or a linear trend line, and also how to get the equation of the trend line up on the chart. We'll do more with this in class, including how to add polynomials and power and exponential trend lines and do the exact same kinds of things.